Hi everyone, just wanted to take a moment to talk a little bit about how to create linear functions from tables of values. And you'll be happy to know that once you kind of get the ability down and the skill down of creating functions from linear from tables, that is really going to help you out a lot with the word problems in this section, given that they're all pretty much related to just creating functions from tables. So once you get it down without the words, really it's the same exact thing. You just now have specific meaning behind the different values. So let's talk a little bit about what is happening in here. So we're going to use the table below to determine whether or not f of x, the function, we want to know whether or not this is actually a linear function. And so for it to be a linear function, it needs to have a constant rate of change. So what we would be looking for is whenever my x increases by 1, my f of x is going to be increasing or decreasing by the same amount, right? It's going to be changing by the same thing. Um, so here we have a plus 1, right? So we are going by 1. That's good. So plus 1. So they are all constantly changing in terms of my x values, right? I'm not all over the place in x values. Like I don't have 0, 7, 14 and a half, 32. It is a constant change in your x, which is great because that means you don't have to worry about bringing it down and trying to find the slope between all the points and things like that. Now, let's look at this side. We have plus 6 to go from there to there. We have plus 6. We have plus 6. All right. So, what do you notice? Whenever we're increasing by 1, my range value is increasing by 6, right? So as you put in a domain that's 1 larger, you're going to get a range that is 6 higher from the one before. So this is changing by a constant amount each time. So this would be a linear function. Again, if you got something that was not a constant change, like you had plus 6, plus 2, plus 3, that would not be a linear function. It could still be a function, but it might not be a linear function. So we need it to be constant. All right, so now our goal is to write it in the form f of x equals mx plus b. Okay, so, well, we obviously know here, right? It is nice enough to give us the 0, 1. So we do have 0, -8. So we do know my b is going to be -8. But now our goal is to figure out what's happening with our slope, right? So just from inspection, you can tell that whenever we're changing our x by 1, our y is changing by 6. And what slope? It's just changing y over changing x. So 6 divided by 1, it's going to be 6, right? And how could you do that if you weren't certain? Well, you could still plug it into the slope formula. These are just ordered pairs. This is 0, -8, 1, -2, right? So I would have -2 minus a -8 over 1 minus 0. So I have -2 plus 8, which is plus 6, over 1 minus 0, which is 1. So it's still 6. So even if you didn't quite reason that out, you could still easily find it and figure it out. So we have f of x is equal to 6x minus 8. And essentially, what is this saying? Every time I put in a value from the domain, you multiply that value by 6 and then subtract 8 from it, and that's your value on your range. All right, so that's really what it's telling you. So let's do it for this one. Let's write a linear function for the data in the table. So again, we are luckily still increasing, plus 1, plus 1, plus 1, plus 1. Now we have to look and see what's happening. So we are decreasing by 1.5, decreasing by 1.5, decreasing by 1.5, and we're still decreasing by -1, right? We're going down by 1.5. So this one is a constant rate of change, so it is a linear function. Again, I am lucky to be given your intercept here, right? So I'm going to write it as a function. I'm going to use function notation. They do give d and y, but I'm going to write it in function notation. It really doesn't matter, right? So what is our slope? Our slope is -1.5. Again, you could do that out using the slope formula if you so desired, but it will be the same, right? X and then plus 7 from our intercept here. Okay, so you just when you're given this value, it's very easy to figure it out. If you weren't given the intercept where x is equal to 0, um, you could easily find it by plugging in any point. You could either use, slope intercept form and solve for b. You could use point slope form and then simplify it if desired. So there's a couple ways you could find it, but ultimately, most of the ones that we're going to be dealing with right now usually do include 0, so it shouldn't be anything crazy. All right, use the table below to determine whether f of x could represent a linear function. All right, so we do need to be careful here. We are now increasing by 2. So that is just something to consider. All right, we are subtracting 3, subtracting 3, subtracting 3. So this does have a constant rate of change. So that's still fine. This is still a linear function. Again, if you had something like -3, -2, -1, that would not be linear. But for our purposes, we have found that it is a constant rate of change. But we do need to be careful because we're no longer changing by 1 up in terms of x. So what could we do? Well, we could plug it into the slope formula. Our 5 minus 8 over 0 minus a -2. So we have -3 over 2. So my slope is -3/2. All right, so you do need to be careful with that. If you had something that wasn't a constant up in the numerator, like let's say we had a table of values where you had something along the lines of, you know, 1, 17, 19, you could still determine that even though this is, plus 16 and this is plus 2, that does not dissuade it from being a function, a linear function. Again, you would still need to figure out if it's a constant change. This one would be one where you have to find the slope between all the points and make sure it's equal. All right. So just something to consider. Okay. So now we have our slope. We have f of x is equal to -3/2 x. And now our intercept is right here, so +5. Okay. So it shouldn't be anything too crazy. Now let's look at that if we were to apply it to a word problem. Again, it's the same exact concept that you've been doing. So Ramona's Garage charges the following labor rates. All customers are charged for at least half an hour. All right. So write a linear function for the data in the table. And then we're going to look at a specific situation. Okay, so we are changing by 0.5. We're adding 0.5, 0.5, 0.5. Okay. And we're changing this by 30, right? So 30, 30. It is always going up by 30. So it is going to be a linear function. We just need to be careful. So again, my slope, if we have 90 minus 60, that's the same with 1 minus 0.5. Okay? So we do get 30 over 0.5. And we're not going to leave it like that, right? That's the same as 30 over 1/2. When you have a fraction in the denominator, multiply it by the reciprocal. So it would be 60. Okay, so my slope is 60. Now you do have to figure out the y-intercept, right? Your b. Alternatively, again, you could plug in some points. So let's see, what do we have? We have f of x at this point is equal to 60x plus b. I'm going to plug in a couple of nice points. Let's plug in the 1. I think that one's probably the easiest, right? You're not dealing with a fraction, shouldn't be anything crazy. So I'm going to do 1. So f of 1 is equal to 60 times 1 plus b. Now we know ultimately that f of 1, based on this information, is 90. So is equal to 60 plus b. So what's my b going to be? My b is just 30. And essentially what's that telling you? That, there's a flat rate of 30. So my function, I forgot the plus. So my final function, after all is said and done, is that f of x is equal to 60x plus 30. And really, what's this telling you, right? For every hour of work you're paying, there's an extra $60. And there's a baseline of 30. Okay. And we know, just for as a point of reference, by the way, there's never going to be a situation where they're just paying 30, right? Because it tells you in the information that you have to get paid. They get paid by at least the half hour, first half hour. So really, essentially, what are we starting at? My domain is actually something like this. I guess in theory they could go on forever. Obviously, it's not in practice ever going to go up to infinity, but just something to consider. Okay, so a repair job took 4 hours, 15 minutes and required $390 in parts. What would be the total cost? So what is this equation actually giving you? This is telling you the cost in labor, right? So this is just telling you how much they're paying for in labor. So essentially, what is 4 hours, 15 minutes? Well, my x is in terms of hours, remember that? So this is 4.25. So f of 4.25 is equal to 60 times 4.25 plus 30. Now, what's 60 times 4.25? So 60 times 4.25 is going to be 225. I'm sorry, 255, not 225, 255 plus 30. Okay, so that is ultimately 285. Now that is just the cost of labor. That doesn't tell you anything about this other component with the parts, right? So we have to include that still when we're coming up with the total cost. So 390. So ultimately, if we add them together, that's the cost of labor, and this is the cost of the parts, right? We get 5, 7, 6. So our final amount that we're going to be paying is $675. All right. So as long as you can determine how to create a function given a table of values, you should have no particular difficulty with a lot of the word problems, as they are largely based on tables. But please let me know if you have any questions. Have a good day.